Welcome to another episode of the Wylie AgCast. Today I'm here with Regional Sales Manager, Mr. Aaron Miller for TeeJet Technologies. How are you doing today?
Very good, very good. It's an honor to be here, Ethan.
Well, thank you. I appreciate you coming and talking to us about TeeJet a little bit and about spraying and things of that nature. Kind of kicking things off, talking about yourself. So what's your story? Were you raised on a farm, or did you kind of stumble into ag sales from a different field, or how'd that happen?
Yeah, no, I'm all farm all the time. I
Okay.
grew up on a farm, a small farm in west central Missouri, and still help out there on the family farm today. And in fact, I almost crawl off a tractor and got on a plane to come down here to be with you. I spent this weekend drilling cereal rye for a cover crop.
Okay.
So, but back in my younger days, I went to the University of Missouri, got a degree in ag systems management, and went straight to work at a local implement dealership and stayed in that business for 26 years. So
Awesome.
I feel like through the years, through the different experiences, I've got a good handle on the challenges faced by the farmers as well as the challenges faced by the businesses that support farmers, and now experience with the challenges that face the ag manufacturers. So
Yes.
I
So what kind of challenges do you see the most of currently?
well, commodity prices right now, ag industry as a whole, I mean, that affects producers and, ag retailers and businesses that support them all the way to the manufacturers. So that's not news. We're all, very well familiar with that. But
Right.
on the manufacturing side, some of the challenges are, our leadership is working in an unforeseeable future all the time. When they are trying to decide direction for the company, they're working in a future where they don't even know if the product that you start developing today is going to be relevant, by the time that it comes to market, maybe even 4 or 5 years down the road. So there's a lot of challenges there. And then once you've decided to invest in a project, well then, sales forecasting numbers and production and making a quality product becomes an issue once it comes to market. So there's just a lot of challenges. Every corner of our industry has got challenges, and it's important that we all, sympathize with that and understand, where other people are coming from, because it's all just people, trying to do a good job. So.
Yes, sir. Absolutely. So TeeJet, what drew you to them and got you started with them?
Mm-hmm. So I don't really remember first learning about TeeJet, but I've done all the field spraying on our family farm since I was a teenager.
Okay.
And then we used TeeJet catalog and reference material in my pesticide application class when I was in college. So from my perspective, TeeJet's just always been kind of a standard of the industry, and something that I've used a lot of their products with over the years. But I will tell you one story. About 2008, when I was working at the implement dealership, we came out with a new rate controller. And we sold a bunch of them, very popular. We installed a bunch of them over the winter, and we went to the field in the spring, and none of them worked.
Oh, man.
And so there was some software programming issues with it, where it was sending a very rapid on-off signal to the section valves, and it was causing the circuit breaker to trip inside the section valve, and then it would quit working. And even though the problem wasn't a TeeJet problem, they sent out some components to dampen that signal to fix that problem to the people that were having that problem. So that really created a lasting impression on me and what type of company that TeeJet was.
Sure. So leadership-wise, I know earlier we were kind of talking about it being such a great company to work for, and what have you seen that kind of gave you that impression?
Mm-hmm. Yeah. So still kind of peeling back the layers on that, and just finding out just great things about the company. It's privately owned. First of all, it's headquartered in Wheaton, Illinois.
Okay.
We have a major manufacturing location there in Wheaton, Illinois, and then another one in Springfield, Illinois. So it's hard to understand TeeJet without knowing more about Spraying Systems Company. So in 1937, two engineers got together and started Spraying Systems Company, which is they started with an 11-page catalog and 6 spray nozzles, and they were all for industrial applications. So the company is still privately owned, and there's just a lot of people there that really care about what they do, and a lot of kids off the farm like me that have a passion for ag business and working on the ag side. So today it's grown. The industrial side of the company serves over 200 industries, just spray application of liquid products and electronic controls for that. We are involved in lots of products that people interact with daily, from scoring bread at bakeries with a water jet to applying stain-resistant coatings to flooring and upholstery and textiles, to putting coatings on vitamins, to spray coatings on cars, and the list goes on and on, descaling steel. So we've got a lot of experience over 88 years with spray nozzles and spray technology, and so that's on the industrial side. They handle 200 industrial industries, and on the TeeJet side, we're just a subsidiary of Spraying Systems Company, and we service the ag market exclusively. So.
Gotcha. So Missouri, that's a completely different area of expertise than around here in West Texas. What kind of, I mean, I know TeeJet is around all over the place, but what kind of got them down here in this market?
Yeah. So we have always had very good U.S. coverage. There's 8 guys that do what I do for TeeJet in the U.S. and Canada. And, kind of going back to being a great company, 2 of those guys have got over 30 years of experience doing this job, for the company.
Awesome.
And so it's hard to believe, but I'm the second youngest of the crew. So, so there's just a lot of experience in that crew. And we work very hard to cover the U.S. and Canada. And actually, we've got sales offices around the globe, as well as some manufacturing operations around the globe as well. So it is a lot different agriculture as you move from here to the Northwest, Pacific Northwest, to Missouri, to the Great Lakes region. So that is one reason why we've got guys like me scattered out across the country, because we are immersed in that local agriculture and understand it, and we just enjoy learning about new things and enjoy all facets of agriculture.
Absolutely. So if you have offices around the world, it means you're probably over in the European countries and things of that nature. Is European farming a whole lot different from the States?
It is in ways, but one of the guys told me the other day that probably very sage advice, but he said that farmers are the same everywhere in the world.
Really?
We can make stereotypes and we can generalize and say Chinese farmers do this and Ukrainian farmers do that, but at its basic level, we're all fighting the same challenges. Every farmer in the world is fighting the weather and fighting the markets and fighting, sometimes government policies and trade policies and things like that. So there's some differences, but there's a lot of similarities everywhere you go in the world. So
well, that's definitely interesting. I've kind of heard that before too. A lot of people have said that it's really not a huge difference when it comes to farmers and what they do and how they do it. Mm-hmm. Equipment's probably different though.
Somewhat, and you see that a lot more now than you did when I was a kid. There is a lot more kind of European flavored type equipment available in the U.S., and I can't speak for if there's more American flavored equipment available over there, but you definitely see a little bit of integration and synergy, in that. So
I just recently learned about ISOBUS. You guys don't just make spray nozzles, you integrate it with the technology of the equipment that you're putting it on. So what, from early mechanical roots to now building, GPS guidance and ISOBUS controls and things of that nature, how did that transition happen? Was it more of an innovative thing, or was it like a we have to do this or we're going to go under type situation, or what?
Yeah, no, that's a very good question. And so it basically just amounts to good leadership and a passion for what we do. And there's just a lot of advantages to providing support for liquid application all the way from the technology to the tip. And electronics have become a large part of what we do, both on the industrial side and on the ag side. And it's rare in the marketplace to find somebody that fully understands spray application out of the tip all the way to the control systems and the farmer's needs and what features are desirable on the farm as far as control systems. But it's the advantages of it that draws them all to it, the advantages of precision application and saving product and reducing expenses and having better yield that brings everybody to the table.
As far as TeeJet goes, there's a lot that goes into spraying. Like we mentioned earlier, there's the electronics, there's the mechanics, there's the science behind it. Do you have to learn all of that to kind of fully understand application and spraying, or is it you can pick up bits and pieces and kind of figure out the rest?
Yeah, that's a great question. So I try and learn as much of it as I can and know as much of it as I can, but that is the great thing about the team that I'm on. I've got a great team behind me. I've got people at the factory that live, eat, and breathe the details on this stuff, and just everybody is great, very helpful, great team members, and so I've had a great experience at TeeJet being able to rely on the people behind the scenes that really know the products in and out, and so I try and focus on practical application of the products on the farm, but I'll be the first to tell you there's a lot of details of how this stuff works that I'm no software engineer, and
Exactly.
there's a lot of things that I don't know about it. So.
Right. Well, that and just the equipment we're running is getting way more advanced, and new integrations. Mentioned ISOBUS earlier.
Mm-hmm.
It's just staying on top of that.
Mm-hmm. Very true. Yeah. It used to be that farmers managed their farm field to field, and it may be a 40-acre field or a 120-acre field or whatever. And so with this precision farming technology, we're trying to move that down to acre to acre. And a lot of it started with like 2.5 acre grids, and then we're trying to move to acre, and tuning that down to square foot to square foot. And eventually the goal is to be able to manage each plant individually and be able to take care of that plant's needs and get a maximum yield with minimum inputs. So that's kind of the trend that we're headed for with precision agriculture.
So what kind of technology are you seeing integrate to be able to do plant by plant management, basically?
Probably a big thing that's on the market right now, there's a lot of talk around it, is target spray application, so that you can actually, the cameras can see the plant, the processor can determine what plant that is, friend or foe, kind of determination, and then actually just spray that plant with the product. And so that's kind of goes back to the same thing of trying to reduce the box. Right now we're at a point where we've got to spray a pretty big box to make sure we get that plant, but that technology is advancing to where you'll see that box get smaller and smaller to where we're just providing that. And then there's even stuff closer to the horizon that is crop care, plant for plant, being able to make determinations through much of the same technology, the vision technology that we have available that can see a plant, that can tell the health state of that plant, and microdose fertilizers and products to it to help it perform at its best.
So are you predicting that maybe broadcast spraying will go away in the future?
No, I wouldn't say that, because there is still a valuable component in soil applied residual type sprays that need to cover every square foot of field. So I think it will be something that's done in conjunction with, and it's just another tool in our toolbox. We've all got the same goal, and we're wearing a tool belt, and which tool are we going to pull out to use for it? So
spot spraying, I've seen a lot of that kind of come out of the market a bit more nowadays, and I have to ask because I'm curious. Does AI play a part in some of that technology?
Yeah, see, that kind of gets past where I'm involved with it, so I couldn't give you a yes or no answer on that. I'm sure probably to a certain extent, and I know some of the challenges have been pulling in images of plants, because for every weed that's out there, you want to have a deep library of images of different growth stages and different angles.
Sure.
And so that it can match that up more closely with the plant that it's looking at. And that can be challenging, because we are already trying to take care of weeds before they get very big. So when farmers have got predominantly clean fields, it's hard to go out there and get good imagery of weeds. So that's been part of the challenge of developing that technology, from what I've been told.
Right. So you mentioned vision earlier. What is that?
That is where a computer or processor can recognize an image that's on the screen. Some technologies are using that, like for a silage chopper spout to follow a truck, to be able to dump in a truck. Of course, the target spraying is using that to be able to recognize weeds. And so you're seeing that more and more. And I'm sure there's probably applications on the road where they're recognizing other cars, against the background of shrubs against the side of the road and things like that. So that's a technology that we're seeing more and more in daily life.
Are y'all building into that a little more, or trying to grow that area of hardware? Or
where we stand right now on that, we've got a very sophisticated PWM system, pulse width modulated system we call DynaJet, and we have created that to be able to integrate with other companies' target spraying technology. And so that it's something that takes factory level work from both companies to be able to integrate that. But once the groundwork is laid, that makes a really great system with a lot of strong synergy. And our DynaJet system has got some unique advantages in the reduction of latency and the ability to respond quickly to that command to spray. And that is something that the industry is trending towards, is trying to be able to react faster and process information faster, and once again go back to reducing the size of that box that they're spraying. So that's where we're standing right now with that technology.
Gotcha. And I guess my question is the goal more focused on eliminating weeds, or is it more focused on a better plant itself?
Both.
Okay.
You're always trying to increase yield while at the same time decreasing input cost.
Okay. And do you see that that's going to cut down on chemical costs and things of that nature?
Yeah, it's the economy is very complex, and so one thing that can be touted about this target spraying technology is that it may of course reduce chemical costs, but you also may open the doors to more expensive chemistries, that since you're applying less of it, you can use a better product, put it right where it needs to be. And so that economy equation is going to play out differently on every farm or for every operator, but there is multiple layers to that equation.
Okay. So moving a little focus on TeeJet itself, you guys did just win an award for the, see if I can read it right, the FM 9380 F75 flow meter.
Yes.
Can you tell me a little bit about what that is and what it does? And
Yeah, we're very proud of that product. So it's an electromagnetic flow meter.
Okay.
It uses electromagnetic waves inside of it to be able to determine how much product is flowing through it. So it eliminates a lot of the problems that you see with a turbine style flow meter. So if you hold that thing up and look through it, there's nothing in the middle of it. There's nothing to clean, no wear parts, nothing to replace. It's got LED indicator lights on the outside for diagnostics, and then it operates over a very wide flow range. So it gives a very accurate signal from 0.6 gallons per minute all the way up to 100 gallons per minute, which becomes more and more important as we get more precise, more precision, and as the industry moves towards individual nozzle section control. So you can accurately read the flow going through the sprayer all the way down to a single nozzle. If it's a 0.6 gallons per minute nozzle, you can read that flow from one nozzle operating up to a full boom width of nozzles. So
is that kind of where you guys are headed as far as your whole product base, I guess?
It is, and there's a lot of advantages to that. And we still produce turbine style flow meters. We've got a new one of those actually coming out that falls kind of in a niche market. So it's not that those are going to be gone forever, but this product is a great upgrade, and it fits just almost every sprayer out there. So if a guy is tired of fighting problems with a flow meter getting plugged, not working right, and or wants more precision, out of that machine, this provides a great upgrade for that. And yes, we are planning on extending that technology.
Awesome. Well, hey, I think it'll make a big difference as far as control. But I guess my question is, the more and more that we open the door for management and I guess every little detail, is that going to increase the complication of farming, or is there I guess a method to make it more simple, UI kind of stuff like that?
Yeah, that's a great question, and it's hard to imagine it getting more complex than it is today.
Yeah.
But I've said that for 30 years, so. No, I do definitely see a trend on making things simpler for an operator to interface with, and trying to monitor functions of a system without operator interaction. Trying to just bring up that light, that indicator light, when there's a problem with that system. And so then that digs deeper into the fact that a lot of times sensors go bad or problems happen that cause a faulty alarm, but we are definitely trying as an industry to reduce operator interaction and letting them focus on a broader range of things that are going on in the cab or in the field.
So with all these new, I guess, software integrations into the hardware, I could say that I see a potential issue with the fact that if the software fails, will that fail the entire system, or is there some kind of, I guess, thoughts rolling around about how to make it work even if the software fails?
Mm-hmm. Yeah, no, that's very true. And software engineering is its own animal. And like I said earlier, I'm not a software engineer,
Sure.
but I do know that the entire system rides on the functioning of that software. And we have our own software engineering team, and we work very diligently to test software before it comes to market, put it through its paces, try every possible scenario. We've got a lot of opportunities to get our stuff out into the field before it comes to market. So we work very diligently and make sure that all that code is working correctly before it actually goes to the farmers.
Sure. Yeah, you don't want it to fail in the field.
That's at all costs. Yeah, that's what we try to avoid.
That would not be good.
Yeah.
I noticed that there is, like, you have your big pivot irrigation type systems that go in a circle and spray, and then you've got your irrigations that I think some go underground, and then you have your self-propelled sprayers, your pull type sprayers. What's the difference between all these sprayers and how they apply, and what's better, what's worse?
Sure. So the big center pivots are typically for applying water, and then, like you say, underground irrigation as well. And there are some very sophisticated systems out there that microdose or inject fertilizers or chemistry or different things into that irrigation water. So that's an option for some products, for some crop care products. But the biggest difference you're going to see between those different types you mentioned is the coverage, is the ability to cover an area and get down to where the problem is or to where the fertilizer is needed. With the broadcast sprayer, you're going to do a lot better job of covering a leaf surface area or getting down below the canopy to attack a certain pest that's giving you trouble. So a lot of what we do rides on droplet size, and so for pesticides, typically they are split between contact and systemic. So a contact product only kills what it touches, so it has to have good coverage over the pest, whereas a systemic product will translocate through the pest and only needs to get a drop of it on there. So that's really the root of spray tip selection, is knowing the product that's being applied, the function of what's trying to apply, and then choosing the best application system, and then down to the best control system, and eventually the best spray tip to be able to get the best efficacy out of that product. So
that brings up the question. I know that most people hear spray tech and they think chemicals and poisons and things of that nature. So what are the farmers actually spraying on their fields as far as today goes?
Sure. So there are a wide variety of products. There are organic and inorganic liquid fertilizers. They're also applied as a spray application, as well as a lot of other products that are meant to enhance plant health and soil health. They're applied out in the field through a spray type application. So the liquid form is very popular for that type of stuff, and there's one way to get it out in the field that's gets it to where it needs to be, and that's through a sprayer or through a spray tip.
So the difference between a liquid fertilizer and a non-liquid fertilizer, is one better, is one worse?
They've each got their place, and that's true so many places in agriculture. So a lot of the macronutrients are applied dry, whereas some of the macronutrients and a lot of micronutrients are applied through liquid, and timing has a lot to do with it. Whether you're applying it in season, and then the application equipment that the farmer has readily available also comes into play. And there's different production techniques for different styles. So as the world market fluctuates, sometimes pricing comes into effect there, economy of different products. So there's a lot of factors involved there, but both are important to the industry, and I'm sure will continue.
So macro and micronutrients, I've never heard that. What is the macro and micronutrients, I guess, of a plant?
N, P, and K, nitrogen, potassium, and phosphorus are typically considered the macronutrients, and carbon can be thrown in there as well, but we don't typically talk about that because it's already out there in nature. So of the applied macronutrients, usually they're talking about nitrogen, phosphorus, and potassium. And then the micronutrients, there's I think 17 total nutrients if I remember correctly, but they are just basically nutrients that are just as important, but applied in a smaller amount.
Okay. And are those crucial? Does the plant get enough of that on its own just through natural means, or is that why, or what they put into fertilizers, I guess, to help them grow?
Yeah, no, that's a very deep subject, and that comes into the kind of the soil health initiative that a lot of guys are working on, okay. And but also there is definitely a need to dose that, sometimes microdose it to plants at a specific time in their growth stage, or even a specific time of day or night. Sometimes it's better to be absorbed by a plant. So that's a very deep subject that would probably need to be more of an agronomist or fertilizer specialist to dig too deep into that. So
okay, so the soil plays a huge role when it comes to the growth of a plant, which is kind of an obvious thing. When you guys are talking about, or when we're talking about spraying and spraying technology and things like that, how much of the soil comes into play when you're building your equipment or building your products?
Yeah, no, it's kind of the foundation of everything. So
Sure.
Both in treatments, crop care products, as well as herbicides, some of them are soil applied and actually keep small seed weeds from germinating that are close to the surface of the soil. So we've got a great chart at the beginning of our catalog that I'm sure a lot of people have seen that have got different applications for spray nozzles, and soil applied is one of the columns there. And then we give a good, better, best rating for each tip that's in the lineup, and allows a guy to choose what droplet size he wants and what is the best tip for that application.
So droplet size wise, what would happen if you got one that's too small or too big?
Yeah, no, that's a great question. So that is very important, and most labels of products that are applied will have a droplet size rating, and so that's kind of where that droplet size starts for a producer, but typically it'll be a range, like maybe medium to coarse droplets. So then there's some room for movement within that range for the producer to decide. But if you half the size of a droplet, you get 8 times better coverage. So it is very significant. And the ISO, the International Standards Organization, has come out with droplet size categories that we use across the industry. So a chemistry label will call for a medium to coarse droplet. Our tip will be rated for a medium to coarse droplet, and a producer can be confident knowing that that terminology means the same thing
Sure.
across the board. So it's very important. That's one reason why we have so many spray tips in our catalog, is because droplet size is such an important factor. And then over the years, technology has allowed us to make spray tips that have more consistent droplet size. So every spray tip out there will have some larger droplets, some smaller droplets, and our research and technology has allowed us to tighten that window and create more consistently sized droplets coming out of the spray tip. So there's actually quite a few things that go into spray tip selection, but droplet size is one of the major things. Yeah, no, that would apply across the board. And
Okay.
so what you get into a lot of times in the more natural products or the fertilizers is that you're targeting the stomata on the leaf. You want the leaf to absorb that nutrient. And so a lot of times they'll have droplet size recommendations on their labels as well as different possibly spraying it through a hose drop or some other piece of machinery that gets the droplets to where they need to be for the plant.
Okay, and of course, when it rains, you can't control the droplet size of rain.
Yeah,
so
very good.
What is, I guess, the benefits of rain versus watering your own crops?
Well, top of the list, rain is free.
This is true. This is true.
Versus all the irrigated water has got to be pumped, typically by some fashion. So there's fuel cost and hardware cost and equipment cost in there, and as well as there's management of an irrigation system. One guy told me it's kind of like having a bunch of kids out there. They're always wanting something. Every system you're running around, irrigator to irrigator, taking care of some need, and so that creates labor. And once you start that, and once you get them started and rolling, you kind of got to maintain that through the season. You got a sunk cost in getting that crop to maturity. So that would probably be the biggest advantage I would say to the rain, is that when it comes in a timely manner, it comes for free. So
Sure. So I'm curious, when you're spraying chemical or whatever it is you're spraying to help either the soil or the plant, of course, I'm sure the plant type matters too, as far as how it's going to absorb. But how much does that actually play a part, the plant versus the spray?
Sure. So there's three things that we judge on an application. So and droplet size affects all three. So we've got coverage, which on a contact product, you want higher coverage, better coverage, and you can tolerate less coverage with a systemic product. You've got canopy penetration, and that comes directly to your question of growth stage of the plant, of the crop, as well as of the weed. And in a canopy penetration scenario, a smaller droplet size gives you better canopy penetration and also better coverage, so that works in conjunction there. And then the third one is drift, and so that works against you. A smaller droplet is more likely to drift. So you're constantly managing. It's kind of like playing a piano, playing those three keys, trying to determine the best droplet size and the best application procedure to get the best results on those three fronts: coverage, penetration, and drift.
So could you possibly give me a little example of that and say, let's go with cotton, since cotton's everywhere around here. As a farmer, what would you do to, I guess, boost or increase the yield of cotton and say, pick the size?
Yeah. So we'll just focus on one, kind of pick on one product, but Liberty, or now Liberty Ultra, is a product that is kind of rare in herbicides, that it's a contact herbicide. A lot of the popular herbicides we use today are systemic herbicides. So when it comes to applying Liberty, we're going to go towards that more. We want better coverage. We're going to do a smaller droplet size. And drift control isn't as big of a concern with a contact type product, because you're less likely to impact your neighbor's crop. So, but then it becomes challenging when you go to do a tank mix where you have a systemic product as well as a contact product in the same tank mix. And so once again, the label is the law. All producers, all applicators reference the label, and you're going to go in a tank mix situation, you're going to go with the largest droplet size that calls for to get the most drift control, and then to get whatever coverage you can, at that droplet size.
So systemic, you keep mentioning that word. What kind of product would be considered a systemic product?
Yeah, so typically your most of your herbicides are going to be systemic, and just to throw a couple out, glyphosate and 2,4-D and derivatives of 2,4-D are all systemic products. So a lot of times spring burn down type applications are done with systemic products, and that sometimes nature works with you, because that's the time of the year that you got typically fighting wind conditions, and so a large droplet size for a systemic product is also excellent for drift control, and so that works very well. So those are a couple of examples of systemic products. Fungicide and insecticide, that are usually later season applications, those are typically contact products. So there's a lot of reasons why a producer can't just have one spray nozzle and expect to do a good job on every application. It takes a variety of different nozzles to do the best job. And that's what sometimes I get asked, why do we provide so many different spray nozzles? And the answer is simple. It's just so that the applicator has got the right tool for the job when he goes to the field.
It's like having that tool belt and pull up whatever you need when you need it.
Exactly. I personally, I am vehemently opposed to crescent wrenches. I don't use them hardly at all, but that's kind of what it boils down to. If you're going to have one spray tip or try and limit your spray tip selection, it's like trying to do every job with a crescent wrench. And for anybody that's done much mechanicking, that's not a good place to be.
No, it is not. So another term I've heard is biologicals. Could you give me a little rundown of what a biological would be?
Yeah. So just kind of like the name implies, it is a biological amendment that's meant to either improve soil health or plant health. And so kind of an interesting fact, if you take a teaspoon of soil, it's got more microbes in it than there are people on planet Earth. And that is kind of a new frontier for us. We're learning how to segregate beneficial microbes and how to apply them in new and unique ways to give more of a natural tilt towards crop production. And so it's a very interesting burgeoning technology. I think you're going to see a lot more from it in the future. But even today, it's got a few application demands, which it's a good thing that we've got 88 years of history of making spray tips for a wide variety of applications. We've got a deep library we can pull into when new innovations come out. But typically, they've got some pretty unique droplet size and flow rate characteristics. They're usually operating sometimes in a very unusual flow rate. We've got to kind of dust off maybe some spray tips that we haven't used for a lot of years to meet that market. But it's very interesting to see how that's developing. I think you'll see a lot more in the future of it.
Man, that's interesting. And do you think that this is kind of more of an economical question, but do you think that the use of kind of biologicals as more of a standard would decrease the cost of more organic product, since it seems to produce more organic product?
Yeah, that's a good question. So I'd say time will tell there, probably so. As far as building soil health and building organic matter in your soil, that's an important thing that all producers are striving for. And there's huge benefits in the ability of soil to retain water between rains if the organic matter is increased. So there's a lot of goals that producers are striving towards. And once again, it's just another tool, in the tool belt to be able to use.
Sure, absolutely. And do you see that most farmers are open to using more biologicals, or is it a growing? I'd say the best question, is it a growing product?
Yes, I think so. From what I've seen, limited sampling of farmers that I know, I don't know anybody that's really against using it or trying it. Some of the barriers are going to be, of course, hardware, if it requires new hardware for them to adopt and pay for. And but if there's yield benefits to it and there's cost benefits to it, I'd say most guys are going to be on board with it.
Awesome. Well, it'd be cool to see that take off, because I think a lot of people nowadays are more natural.
Absolutely, yeah.
So moving into a little more of the actual spraying itself. So if a young farmer asked you if they should feel guilty about spraying chemicals at all, what would you tell them?
Yeah, that's a great question. So I would tell them, the market today demands plentiful food at an affordable price. And farmers are only trying to produce a marketable product. As the market demands change, farmers are going to flex and farmers are going to change to provide that marketable product. And as long as that farmer is feeding his family the same food that he's producing, as long as he is willing to eat at a restaurant or buy food from a grocery store, then I see no basis for guilt at all. And agriculture is a unique industry. Everybody in this country is a consumer, and there is no line between a consumer and a producer. Some of us happen to be consumers and producers,
right,
but everyone's a consumer.
Right. So
as long as people remember that we're feeding our families the same food that we're producing and putting into the food supply, I think that's an important thing.
Is there any myths that you could, debunk about spraying and spraying technology?
So that's a great question, Ethan. So I would have to say that the general public, I think, really has a great underestimation of the difficulty in producing a stable and affordable food supply and fiber supply as well. So When you go to any agronomy training or university presentation, it's just amazing the number of weeds and insects and diseases that are out there attacking our food and fiber supply. And so today, as we try and produce that, the liquid products, the chemistry that we have available are a very valuable tool to fight that. And excuse me, I saw a study the other day, the Weed Science Society of America sponsored a university study where it depends on the crop, but roughly 50% of yield is attributed to weed control practices. And that doesn't even address insects and disease. Man. So those farmers are out there every day just fighting really hard to get a yield and to take care of the environment and to reduce input cost. And so I think that's probably the greatest myth, is just not an understanding of how difficult it actually is to keep the shelves full at the grocery store.
Yeah, I mean, it fascinates me. The more and more I dig into agricultural and talk to people and learn things, there is a massive complication that goes into growing a crop. Except, people can just say, oh, you go out there, you plant it, you water it, you spray whatever you need to spray, and then it grows and you leave it alone. But that is not the case.
Exactly. And I've heard that a lot. People think that, farming is easy because of that.
Yeah.
But the challenge I like to place on that is that, yes, growing a single plant can be easy, but trying to do it on a mass scale and trying to do it profitably so that you can afford to be in business next year and put out the next year's crop, therein lies the difficulty.
Exactly, yeah. And, you've got these smaller farmers that they have to work, I would say, a little harder. So shifting the focus a little bit to the product and the hardware side of things, ag equipment gets absolutely abused. I would say probably out of any equipment, it probably gets the most rough treatment. What are the biggest durability challenges you see, and what's TeeJet doing to kind of combat that?
Yeah, and you are right. And but I've got a lot of sympathy for the farmer. The farmer's got a lot of demands for their time, and sometimes demands for their time conflict with the demands that it takes to properly maintain equipment. So, there's a good reason for why farm equipment is abused like it is. And two things that probably affect us more than anything are boom strikes. You got a 120-foot boom typically, 60-foot off center hanging out there. And, as much as an operator tries to keep that out of the dirt and keep it from, hitting a fence post or a power line pole or, sometimes a tree or something, sometimes bad things happen. And as far as TeeJet's response to that, we could probably build boom components that were built, kind of in a bulldozer type fashion that could withstand boom strikes. But the problem is that they would be so heavy and so expensive that you couldn't afford to put, 90 or 100 of them on a boom. And it would it'd be so heavy, make it harder to control that boom, and it would be more likely, to strike something. So what we have done on that front is we've made our nozzle bodies. We just put a lot of effort into engineering those nozzle bodies so that they're quick and easy to replace with just one tool. If you got a number 3 Phillips screwdriver, you can replace that nozzle body that hits something and breaks off, in the field and keep going. And another thing that we see a lot of is just guys not rinsing booms out like they should. And with liquid fertilizer, there's really no agronomic benefit to rinsing that boom out because that fertilizer is not going to hurt the next crop that you spray. So a lot of times a guy will just turn his turret and go to a herbicide nozzle and just go on and keep on spraying. And what that causes from our perspective is it just lets that fertilizer nozzle sit and soak in liquid fertilizer for a year probably till you use it again. And that's hard on materials, and I don't care what material that nozzle is made of. It's that liquid fertilizer and the components, the additives in that liquid fertilizer are going to work on those materials. So one thing we've done to combat that front is we just recently started offering the internal components of that liquid fertilizer nozzle separate from the whole thing, so that it's when that does happen, that's more reasonably priced for a producer to go and fix that problem. He doesn't have to buy the whole fertilizer tip. He can just buy the internal components of it. So, that's one of the challenges of manufacturing is we constantly strive every day to make stuff as durable as possible and to be able to stand as much abuse as possible. But there's weight considerations, there's cost, considerations that come into that. So You can't make something that will last through all of the abuse, but is too expensive for a guy to be able to afford to buy. So there's got to be a balance in that, and we work hard every day trying to achieve the best balance on that.
So curious, when you're building or what goes into the manufacturing of a spray tip, are you considering the, I guess, material it's actually made of? Because I know plastics absorb a lot of that, and I'd assume that most, if not all, farmers don't use the same tip for liquid fertilizer as they do for like a pesticide or something like that, so that it doesn't, like you said, if they don't rinse it out, then it absorbs all that. And so what kind of material are y'all building these out of to kind of avoid that?
Excuse me. Yes, that's very true. And we do make most of our products out of a variety of materials, give the producer the choice of material that he wants to use. Sometimes we like to say we're material agnostic. We offer whatever you want to use, and each material has its advantages and disadvantages, both in resistance to the chemicals and the products that are going through it, as well as to abrasion. Some products are more abrasive than others, and even to going back to the abuse, it's very important that you clean a spray tip properly. Some guys will get out an O-ring pick or a toothpick and can ruin a nozzle pretty quick if it's a poly nozzle. So a lot of our poly products will wear similar, actually surprisingly enough, to stainless steel, but the stainless steel product is going to be more resistant to that abuse that tips sometimes get. So we have got some very sophisticated manufacturing techniques for ceramics. So we provide tips in ceramics as well as stainless steel and poly. And going back to the early days, brass, there's a lot of brass tips, which we kind of use as the baseline for wear resistance, for the worst wear resistance. The other products we compare to brass as how much better they resist wear than brass.
So I guess my next question would be, is there a material that you would say is the best that you would recommend for most general application?
Absolutely not.
No?
No. We provide a wide variety of materials that each have their own separate individual strengths and weaknesses depending on the application they're in. So I would not recommend one material as a good general material. So probably the closest I would come to that is just our standard poly material. It has got very good wear resistance. It does not have very good abuse resistance. So you've got to have a conscientious operator that is careful cleaning a poly tip. But that is definitely the most common material that we use in the U.S. And it's an excellent material. We actually have people in the factory that inspect tips as they come off the line before they make it out to the farmer. So we take product quality very seriously. A poly tip will wear out over time, and that depends on the product that you're using and even pressure. The pressure you're operating, a higher pressure will wear out a tip faster than operating at a lower pressure. So in its most extreme sense, I would have to say yes, there is small particles of that tip get left behind as you go through the field, but it would be so minute, it would be just hard to even measure, because that spray tip is actually going to last over a lot of gallons and a lot of acres before it shows any appreciable wear.
Sure. Well, and I guess that would also be on the farmer to keep an eye on it, and if it's wearing out, probably be a good time to swap it.
That's very true, and that's a huge subject, and that's something that we see. We kind of try and beat that drum as we travel around, because we recommend that farmer calibrate a sprayer at least once a year, and by going through that calibration process, that process is laid out in the back of our catalog, but by going through that process, you get a feel for the condition of your nozzles, and they do wear out over time. And with today's use of automatic rate controllers, I get farmers that tell me, well, it tells me that I have enough to spray 40 acres and I sprayed 40 acres, so everything must be okay. Well, that automatic rate controller is adjusting rate based on flow. So it's going to put out the right, if it's functioning correctly, it's going to put out the right amount no matter what condition the tips are in. But the problem you get into is that it may be at the wrong pressure as tips wear. That pressure to get that right flow rate changes, and your pattern may be bad. And so you may not be putting out the droplet size that you want. As we talked about earlier, droplet size is extremely important. And as a farmer myself, I'm going to tell you the rules of farming is that if you've got a bad pattern and you've got a place where you're not putting on as much product as the other, that is where that biggest, gnarliest weed that needs the most product to take care of is going to fall. It's always going to fall in that area that's getting the least amount of product. So that is something that's very important out there, is to do a sprayer calibration at least once a year, get a good feel for the condition. And when you take the cost of a set of nozzles and you spread it out over the number of acres they cover, the cost per acre for keeping good nozzles, the right nozzle selection in good condition, is really minimal. And that's not even counting the dollars of product that's flowing through those nozzles and the risk that you're putting out there in the field financially to make sure you get good efficacy out of that product. So it's a very good equation. You just have to ask guys to make sure they do that at least once a year.
Sure. I'm curious, is there a system in place, kind of like, I guess, if your tire gets low, then it'll alert you? Do y'all have something kind of similar to that to let you know when it's a good time to replace a nozzle?
We do, and that's fantastic. So we have it doesn't necessarily judge the wear on a nozzle, but being unique in the marketplace that we provide nozzles all the way up to the tech, all the way up to the toggle switch that turns the nozzle on and off. We do have a product called Sentry that is very easy to install. It's economically priced, but it taps into the pressure gauge circuit and will monitor pressure. And then it's a display that goes in the cab, and it's got all of the TeeJet rate charts loaded in it. So you just tell it what TeeJet tip you're using. It monitors the pressure as you move through the field, and then it will consistently tell you the droplet size that you're applying. So those guys that are really concerned about droplet size and maybe in challenging environmental conditions, gives you an excellent way to keep track of the droplet size and maybe adjust your speed, adjust your flow rate a little bit to maintain the optimum droplet size for each application.
That's pretty awesome. That's a cool system. I think it would be very beneficial to use on a consistent basis. So this is a interesting, I guess, question, but I've seen drones kind of taking off in the market. Do you see that that's going to be something, or is it kind of just a cool thing for now and then it'll go away kind of situation?
Yeah, actually I've seen drones taking off lots of times.
Yeah, right, exactly.
Sounds very good. So yes, they are definitely a force in the marketplace, and from a spray tip perspective, they do have some unique requirements. And so when you knock it down to its most basic functions, a spray tip has got three things that it does. It regulates flow, it creates droplets, and it disperses a pattern. And so then when you put a spray tip on a drone, well, the 80-mile-an-hour wind coming off that rotor commandeers that third function. So now your spray tip is only doing two of its three functions. It's only regulating flow and creating droplets. So I've had people tell me that we should come out with spray tips for drones, but the actual truth is most of the spray tips in our catalog are excellent for use on drones. The drone operator just has to tell me what flow rate they're after and what droplet size they want, and we can pick multiple tips that will provide that flow rate with that droplet size, and then let the drone take care of the pattern dispersal.
Do you think a drone is a better or worse method of application?
That's a lot deeper subject, and there is a lot of pros and cons. Just like every different type of application out there, there's pros and cons to it. And so it's definitely a very valuable tool in the tool belt to pull out at certain times. So, but to say that it's unequivocally better than other application methods would be hard to do.
So to kind of close out a little bit, could you run me through start to finish the maintenance that a farmer would need to do to maintain a proper spray tip and spray or application at its most efficient state?
Yeah, absolutely. And so probably that starts when you finish your application project, rinse everything out, clean everything out. I mean, that's kind of the first step in proper maintenance on a spray application system. And second of all, we talked about doing the calibration. Do that at least once a year. When it comes to cleaning tips, if you do get something that is clogged, it's very important to use a soft bristled nylon brush. We provide a brush. Actually, we sell a brush that's made specifically for that use, and even an old toothbrush can be used. But I caution on that because you don't want a kid to pick up an old toothbrush and stick in their mouth or something. So yeah, that would be a bad deal. So, but don't use a toothpick. Don't use an O-ring pick. So that is important. And then the next thing is tip selection. Just make sure that you're using the right tip for the right job, right droplet size, right spray pattern. And as long as you've got a good catalog of tips available to use for each application, and you're taking good care of them, and you know what you're putting out as far as droplet size and as far as rate, you should be good to go for an excellent experience applying liquid product.
Awesome. So is there anything in TeeJet's pipeline that you're most excited about in 26, 27?
Yeah, there is. Probably the first thing to think of is this FM9380 electromagnetic flow mirror we talked about.
Yes.
We are extending that product line, and so we've got a new one that's coming out that's going to have a lower flow rate. It's going to work at a 0.02 to 1.5 gallon per minute flow rate, whereas the FM9380 that's out now operates at a 0.6 to 100 gallon per minute flow rate. So the advantage of that primarily is that it's row level monitoring for a planter or a liquid fertilizer applicator that's putting on dosing product on a row to row basis. This is an excellent product for that, as well as maybe some new technologies that are coming out that need low flow rate. It carries the same advantages as the larger flow meter. You look straight through it. There's nothing in the way, no moving parts, nothing to clean. It's got LED indicator lights on the outside, and once again, it's very accurate, that lower flow rate. You're going to see an expansion of our tip line into more complex ceramic shapes for guys that find ceramic to be the best material to use for their application. And then there's new boom components probably that will be coming out. And so our company is built on innovation and engineering. Our founders were engineers, and our CEO today has an engineering background as well as being the grandson of the founder. And so innovation is very important to us, and our pipeline is always full, but it's the timeline, that sometimes it surprises even us on bringing products to market. So.
Yeah. So for growers listening who feel maybe overwhelmed by all the high-tech stuff, what's your one piece of kind of timeless advice that still applies no matter how fancy equipment gets?
Yeah. So I would say that, no matter how fancy equipment gets, the basic rules of agronomy still apply, and the things that they have honed, the skills they've honed through a lifetime of doing this still apply, and that gives them a good basis to judge new technologies and see if they want to adopt them or not. And for timeless advice, there's only one place to go. I came across Leviticus 26, 3 through 12 here the other day, and thought that was very meaningful as it applies to modern agriculture and even in the nation as we see it today. So.
And what does that one say?
It talks about if you keep God's commandments and His statutes, then He will provide rains in their season, and a good plentiful harvest, and goes through some details on that. But
absolutely,
yeah. Well,
He controls all things.
That's right.
So, good faith is always a good foundation.
Mm-hmm.
Absolutely. So I'll finish everything off. I'd just like to open the floor. If there's anything you'd want to impart, some words of wisdom, or all up to you.
Yeah, I don't know if I got any words of wisdom, but from my perspective, TeeJet really is a great company, and when a farmer or rancher chooses a TeeJet product, he's supporting a company that respects their employees, respects their customers, and places a priority on U.S. manufacturing. There's a lot of talk about trade deals and tariffs and all that, and so I think in today's climate that is maybe more important than it has been in the past. And so I want to reach out and say thank you to everybody out there that has purchased the TeeJet product or is contemplating a TeeJet product purchase. The people at TeeJet really appreciate that business, and we strive every day to make things clean and efficient for our customers and producers, and that goes from us guys out in the field to the customer service to the tech support department. We all, to manufacturing, to engineering, we all work very hard and strive to provide a good product for you.
Awesome. Well, Mr. Miller, I appreciate you coming by and talking to me. And
well, thank you, Ethan. It's been a great honor to be here. I appreciate the invitation.
yes, sir.